So number 1 is absolute value. So find the solution set for the equation. So to start solving this, we're going to get the absolute value by itself. So in order to do that, I need to get rid of this 3 times the absolute value. So I'm going to divide by 3 on both sides. That's going to cancel out this 3 on the left. So on the left, I have the absolute value of 2x minus 3 equals 15 divided by 3 is 5. So now I'm ready to do my 2 equations for absolute value. So the first one's going to, I can drop the absolute value, and the equation is going to be exactly what you see minus the absolute value symbols. The other equation, we're going to write the left side the same, but we're going to negate the right side or do the opposite of 5, which is negative 5. So now we're going to solve these 2 equations. So to solve for x in the first, we'll add 3 to both sides. So then we have 2x equals 5 plus 3 is 8. Divide by 2 to solve for x. So x equals 4 is one of my solutions. And in the other solution, I'm going to add 3 again to get the term with the x by itself. Bring down that 2x equals negative 5 plus 3 is negative 2. And then to solve for x, I'm going to divide by 2. So x equals negative 2 divided by 2 is negative 1. So these are my 2 solutions. So it says to find the solution set, and the way that they want you to type it in MyMathLab is to type it as a set of numbers. So it would already have the bracket set up for you, and you would put something inside the bracket. So you can just type negative 1, comma 4 to represent that's a set of solutions for the equation. All right. Okay. Let's keep going. Number 2, solve the inequality and graph the solution set on a number line. So we're trying to solve for x. So I want to get this by itself. So in order to do that, I'm going to subtract 2 on both sides of the inequality. So what's going to happen is that in the middle, I'm going to just have that 3x. And on the left, negative 1 minus 2 is negative 3. Bring down that less than. And then I already have my 3x. Bring down that less than or equal to. And then 8 minus 2 is 6. All right, so now, again, to solve for x, I'm going to divide by 3. Actually, I don't have any questions. Okay. Oops. All right, I'm going to divide by 3 everywhere. So on the left, negative 3 divided by 3 is negative 1, is less than 3x over 3. The 3's cancel out, and I just have x is less than or equal to 6 divided by 3 is 2. Now here's the spot that people get confused. I did not flip the inequality signs because I did not divide by a negative. The only time you flip the inequality signs is when you divide or multiply by a negative in an inequality. So that's why I did not flip the inequality signs. Now if I was dividing by negative 3 everywhere, then I would flip the inequality signs. So I have 2 different inequalities basically. So this first one here, let me write it so the x is on the left-hand side. So negative 1 is less than x, the same thing as saying x is greater than negative 1. And then I have this one here, x is less than or equal to 2. All right? So this is an and inequality, so let's see what's going on. So I'm going to graph these on the number line. So I'm going to say if this is, make that 0. I'll make this negative 1. This will be 1. This can be 2. Okay. So x is greater than negative 1. So here's negative 1 here. I'm going to use a open circle and x is greater than -1, I'm going to shade to the right. Or if you use parentheses and shade to the right, that's also how it would look. Let's do the other one, x is less than or equal to 2. So here is 2. That's going to be a closed circle because I am including 2, and all the values less than 2 are to the left. Or if you were to use a bracket to represent that equal to, and shade to the left. Okie doke. So the graph of the solution looks like wherever they overlap. So the graph is just this part here. The solution to the graph is the part I highlighted. So if I were going to draw that on a number line, you would only include the part that's overlapping. And in interval notation, it looks very much like the graph. So you always start from left to right. So from the left, it's starting at -1. But we're going to use parentheses because we're not including -1. And what we're doing, we're describing this interval here. So it's going from -1, comma, all the way to 2. But we are including 2, so we're going to use a bracket. So this would be my graph of the solution in black, or this here in black is the graph of the solution, and the solution in interval notation would be my interval here. All right? Okay. Number 3. Write the point-slope form of the equation of the line satisfying the given conditions. Then use the point-slope form to write the slope-intercept form of the equation. So let's remember what point-slope form looks like. Point-slope form is y minus y1 equals m times x minus x1. All right, so to use point-slope form, we need a slope and we need a point. And we only have we have 2 points but no slope. So we're going to start off by finding the slope. Okay, that's a little thin. Okay, that's a little thin. That's a little better. Save some space. Okay, the slope, we use the letter m. And so to find the slope of a line given 2 points, that formula is y2 minus y1 divided by x2 minus x1. So let's label these points. So the first point, I'll call that x1 and y1. And the second point, I'll call that x2 and y2. So we're going to plug in these values. So m equals y2, 8, minus y1, -7, divided by x2, 2, minus x1, -3. Okay, so 8 minus -7 is the same thing as 8 plus 7, which is 15. And then 2 minus -3 is the same thing as 2 plus 3, which is 5. And so 15 divided by 5 equals 3. So the slope of the line that we need to write is 3. So now we have the slope part of point-slope form. And then now we need to just choose a point for the point part of point-slope form. And so you can choose whichever point you want. I'm going to choose this one. It doesn't really matter which you use. So the point 2, 8 is going to go in for x1 and y1. And then the slope goes here for m. Okay, so we've got y minus y1. Well, I probably should have used the other one because I already had it labeled. Okay, doesn't matter which point you use. I'm just using this one because they're positive numbers. But I'm going to use the point in green. But I hope we all understand that you could have used the first point. And for the sake of the video, I probably should have used the first point because I've already got them labeled, but it doesn't matter which point you use. Okay, so my y for the point that I chose is 8 equals m, the m I found was 3, times x minus the x for the point that I chose is 2. Just so we're clear, this 3 is the slope that we found based on the 2 points, and then this 2 and this 8 comes from this point. That's the point that I chose to use. All right, now let's finish it. This is point slope form. So if it asks you to write it in point slope form, that is point slope form. Now to write your answer in slope intercept form, let's go ahead and simplify. So remember that slope intercept form is y equals mx plus b. All right, so let's distribute the 3. So I have 3 times x is 3x. 3 times negative 2 is negative 6. Then I have y minus 8 on the left. But I want it to be y equals everything else. I'm going to add this 8. So then I have y equals 3x, and then negative 6 plus 8 is positive 2. So now this is point slope form. So both of these equations are the same line, they're just written in a different form. Okay? Okay, so your point slope form will look different if you choose the other point, but it's still a correct answer. But when you change them into slope intercept form, you will get the same slope intercept form. Okay. Let's look at number 4. So number 4, use the conditions to write the equation of a line in point slope and slope intercept. So I'm going to rewrite those forms up here. Okay. So it's passing through the point 9, negative 4, and it's perpendicular to the line whose equation is y equals 1/4 x plus 2. Okay, so remember, if we want to start off in point slope form, you need a point and a slope. So we have a point. We have, no, oh goodness, I didn't mean to do that. Sorry, guys. Sorry. Okay, all right. So we have a point. The point they gave us is 9, negative 4. So what we need to find is the slope. Okay, so the slope of our line is perpendicular to this guy here. So it's perpendicular to y equals 1/4 x plus 2. So perpendicular lines have negative reciprocal slopes. So this slope is 1/4. So the slope perpendicular to 1/4 is the negative reciprocal. Or you just flip and change the sign. So the slope that we need, m equals 4/1, and then we change the sign. So we took that 1/4, we flipped it, and then we changed the sign. And negative 4/1 is negative 4. So that is the slope that we need. So we have a point, we have a slope, so we can put that information right into point slope form. So y minus negative 4 equals m. The m we want to use is negative 4 times x minus x1, the x coordinate of the point that was given to us, which is 9. All right, so now y minus negative 4, add the opposites, that's y plus 4 equals negative 4 times x minus 9. So this is point slope form. To write it in slope-intercept form, let's just continue and multiply and see what we get. Okay, so if we distribute this negative 4, negative 4 times x is negative 4x, and negative 4 times negative 9 is positive 36. I'm going to bring down that y plus 4, and then to get y by itself, I'm going to subtract 4, and we have y equals negative 4x plus 36 minus 4 is 32. So this is slope-intercept form. All right. Okay, any questions about that? Okay. So number 5, now we're solving systems. So I do ask for certain methods, but to be honest with you, I'm not going to know which method you use, so you can technically use whatever method you're most comfortable with, but I'm going to use the method that I specify. So solve the system by the substitution method. So the substitution method means that you have to choose this equation, set it equal to a variable, and then substitute that expression for the variable in the other equation. So I'm going to start with this first one because it's already almost got a variable by itself. So if I have x plus 3y equals 6, if I subtract 3y, then I will solve for x and have x equals negative 3y plus 6. So what I can do now is take this expression for x and plug it in for x in the other equation. So what I'll have is 4 times negative 3y plus 6 plus 3y equals 15. Okay, so now I'm going to distribute that 4. 4 times negative 3y is negative 12y. 4 times 6 is 24. Bring down that plus 3y equals 15. And now I'm going to combine like terms on the left. So negative 12y plus 3y is going to be negative 9y. I have plus 24 equals 15. Now I'm trying to solve for the variable. So I'm going to, hold on one second. Okay, so now I'm going to subtract 24 from both sides. So I'm going to have negative 9y equals negative 9, because 15 minus 24 is negative 9. To solve for y, divide by negative 9. So y equals positive 1. That's half of my solution. I need to get x so that I can have my solution, which is a point. So I already have an equation here solved for x. So I'm going to take what I got for y and plug it in here. So I'm going to have x equals negative 3 times 1 plus 6. So negative 3 times 1 is negative 3 plus 6. Negative 3 plus 6 is positive 3. So that's the other half of your solution. So the solution is a point, and that point is x comma y, which would be 3 comma 1. So that is the point where these two lines intersect if you were to graph them. And then if you want to check your answers, you could take that point, plug it into both equations, and it should give you a true statement for both equations. Okay? Okay, 1 second. All right. Okay, let's solve another system using the addition method. So we have a system here. We're going to solve it using the addition method. It's also known as the elimination method. So for this method, you are trying to eliminate one of your variables by adding the equations together. So you want to create opposites in one of your variables. So you may have to multiply an equation by some number in order to create opposites. So I can see here that if I were to multiply this first equation by a -5, that will create -5x, which will be the opposite of +5x in the other equation. And if I add those two equations up, then the x's will completely go away, and I would have eliminated a variable by adding the equations together. So let me do that multiplication first. So if I distribute that -5 with this first equation, I'm going to have -5x. -5 times 4y is -20y. Then -5 times 5 is -25. I'm just going to rewrite the second equation so it's the same size. I'm just rewriting the second equation. And so now I'm ready to add these equations vertically, and it's going to eliminate a variable. So -5x plus 5x cancels out. That was my goal. So now I have -20y plus 3y. It's going to give me -17y. And then equals -25 plus 8 equals -17. Then to solve for y, I'm going to divide by -17. So y equals +1. Again, that is half of my solution. To get the other half, I need to take this value for y and plug it into one of my equations. Doesn't matter which one you use. I'm just going to rewrite the first equation and use that one. So I'm going to take what I got for y and plug it in for y into one of your equations. So that's going to be x plus 4 times 1 equals 5. So 4 times 1 is 4, so x plus 4 equals 5. And then to solve for x, I will subtract 4. So x equals 1. That's the other half of my solution. So my solution is the point x comma y, which in this case will be 1 comma 1. Close parentheses. Remember, I went back and checked some of your tests recently, and some of you, the answer was a point, but you didn't put parentheses around your point and didn't count it right. I went in and gave you credit, but please know that you are entering an actual ordered pair here. So you want to put your parentheses in your solution. All right. Number 7. So we have an interest problem. You will have one of these on your final. So remember, wait a minute. Oh, I should have known I was going to do that. Okay. So that interest formula is it's I equals PRT. Okay? So you invested $9,000 between two accounts paying 4% and 6% annual interest, respectively. If the total interest for the year was $460, how much was invested at each rate? All right. So remember, the I equals PRT, or the PERT formula. So I represents your amount in interest. P is your principal, or what you invest. R is the rate, and T is time in years. Now we have two different scenarios, so I like to create a table to help organize this information. So we've got interest, principal, rate, and time. Not around the room. And then we have two accounts. We have a 4% account. We have the 6% account. And then we have the total. All right, so let's see here. You invested $9,000 total between two accounts. So your investment is your principal, and the total that you invested was $9,000. So I'm going to put that in this principal total principal. So now so the two accounts are paying 4% and 6% annual interest. So that amount is going to go under your rate here, but we have to put it as a decimal. So 4% as a decimal is 0.04. 6% as a decimal is 0.06. If the total interest for the year is $460, so your total interest is $460, how much was invested at each rate? So we want to know what was the principal for each rate. That's what we're solving for. So that's what around variables need to go. So why don't we call how much you invested at the 4% rate X, and how much you invested at the 6% rate Y. Okay, so what is the time? So how many years was the investment for? It's just for 1 year, so we're going to make them both 1 and 1. So remember, P times R times T equals I. All right? So what we need to do is that we need to multiply what's in these columns, or what's in these rows, to set equal to the interest. So basically, X times 0.04 times 1, which is 0.04x. And then Y times 0.06 times 1 is 0.06y. And then the way this table works is that we're going to add going down. That's going to give us our two equations for our system. So using the interest and the principal. So the first one is this. So I'm going to have 0.04x plus 0.06y equals 460. That came from that first column. And the second column is going to give you your other equation. X plus y equals 9,000. Whoa. Okay. Sorry, guys. I'm going too fast here. And that is our system that we're going to solve. So you can use whatever method you want to solve this. Yeah, whatever you want. I'll use substitution. Addition wouldn't be bad to use either, but I'll use substitution. So I'm going to choose the green equation and solve for x. It doesn't really matter which variable you solve for. So let's see. So if I solve for x, I will subtract y. So I'm going to have x equals 9,000 minus y. So I'm going to take this expression and plug it in for x in the other equation. So I'm going to have 0.04 times 9,000 minus y plus 0.06y equals 460. So I'm going to distribute that 0.04. Use your calculator. 0.04 times 9,000 is 360. 0.04 times negative y is negative 0.04y. Then bring down that 0.06y equals 460. Now we're going to combine like terms, which are your y terms. So 0.04, negative 0.04 plus 0.06 is going to give me a positive 0.02y. Bring down the 360 and the equals 460. I'm trying to solve for y, so I'm going to subtract 360. 0.02y equals 100. Let me get an extra page here. Hold on, let's see. Whoa. Okay. And then to solve for y, I'm going to divide by 0.02. So, what? Okay. It didn't like me going through pages. That's okay. Alright. Sorry, guys. I'm trying to use different technology here. Okay. Divide by 0.02, so we have y equals 100 divided by 0.02 is 5,000. Okay? Now, to get x, I need to take this amount that I got for y and plug it in for y, and the other equation, and we already have one set equal to x, we'll plug it in right here. So we have x equals 9,000 minus y, which we now know is 5,000. And so 9,000 minus 5,000 is 4,000. X equals 4,000. Now, your final is going to ask you, okay, what do those numbers mean? So it's going to ask you the way I have it at the top. So it says that what amount was invested at 4%? So 4%, that amount is x. So x equals 4,000. And what amount was invested at 6%? 6% is your y. That was 5,000. So it's really important to know what your variables are representing when you solve it, because you can do all this good hard work, and if you forgot what x represented and what y represented, which is why this table is nice, or if you just want to put on the side x equals the 4% and the y equals the 6%, then that's fine too. Okay, let's keep going. All right, another system of equations. So at a concession stand, 1 hot dog and 1 hamburger cost $2.75. 1 hot dog and 5 hamburgers cost $8.75. Find the cost of 1 hot dog and the cost of 1 hamburger. Okay, so this first statement tells me my information for the first equation. But first, let's designate what our x and y are going to represent. So let's make x represent your hot dog and y represent your hamburger. So 1 hot dog and 1 hamburger equals $2.75. Or you can, of course, write that as just x plus y equals $2.75. The other equation says 1 hot dog and 5 hamburgers equals $8.75. So you can just say x plus 5y equals $8.75. And so now we want to solve this system. So let's use the elimination method just to change it up. So I can add up these equations to get rid of a variable if I multiply one of them by -1, for example. Then I can get rid of the x's. So I'm going to change this to negative x minus 5y equals negative 8.75. If I do that, if I distribute that -1 everywhere, I get what I have in blue. I'm just going to rewrite the first one just so we can see it together. And then now I can vertically add these up. And what that's going to do is get rid of my x terms. So negative x plus x is nothing. Negative 5y plus y is negative 4y. And then negative 8.75 plus 2.75 is negative 6. And then we're going to solve for y by dividing by -4. So y equals negative 6 divided by -4 is positive 1.5. Now to get x, we have to take one of our equations. I am just going to choose the first one. X plus y equals 275. I'm going to take what I solved for y and plug it into one of my equations. So I have x plus 1.5 equals 275. And to solve for x, I will subtract 1.5 from both sides. So x equals 2.75 minus 1.5 is 1.25. So it asks you the cost of one hot dog is and the cost of one hamburger is. Well, again, if we wrote down what x represents, what y represents, x represents the cost of a hot dog. So I'm going to write 1.25, $1.25 is the cost of a hot dog. Then a hamburger, the cost of the hamburger is $1.50. Okay? Any questions about that? All right. Now we have some division, dividing polynomials. So we're going to use long division. In order to use long division, we need to make sure that we have the polynomials in standard form. So the dividend is the expression at the top, but I'm going to write that as y squared plus 5y plus 21. So I have to rewrite the order so those exponents are decreasing. And the divisor is y plus 2. That goes on the outside. So it's y squared plus 5y plus 21 divided by y plus 2. So to divide using long division, we're going to take the leading term, y squared divided by y. All right? So we're saying y squared divided by y. That equals y. That's what's going to go up here. Now we're going to multiply y times y plus 2. So y times y is y squared. Y times 2 is positive 2y. Next what we're going to do is subtract the entire thing. Okay? So when you do that, you're basically changing all the signs. So if you want, you can just change up all the signs. But you're going to do y squared minus y squared cancels out. 5y minus 2y is 3y. And then now we're going to bring down that plus 21. Now we're going to do it again with the leading terms. We're going to say 3y divided by y. So 3y divided by y equals 3. So we're going to write positive 3 up here, and then we're going to multiply. 3 times y is 3y. 3 times 2 is 6. Then what we're going to do is subtract the entire thing. 3y minus 3y cancels out. 21 minus 6 is 15. So this is your remainder. Okay? And so how do we write our answer? Oh, why do I keep doing that? Okay, so the answer, the quotient, is going to be y plus 3, what we have up here, plus the remainder, which is 15, divided by the divisor. So the way that you write your answer is that it is the quotient, which you get on top of that division box, plus the remainder divided by divisor. Okay? Why do I keep doing that? Oh my goodness. I know it's probably driving y'all crazy. I'm so sorry. Okay, just to use my colors. So the quotient is this. The remainder is this. And the divisor is this guy here. Okay? All right. Any questions about that one? Okay. Let's keep the party going. Factor the difference of two cubes. So you do need to know that factor pattern. So a cubed minus b cubed. And we'll also do a cubed plus b cubed just so you can see it. So the way that factoring pattern is it's a minus b times a squared plus ab plus b squared. Just so we can have it, a cubed plus b cubed is very similar. It's going to be a plus b times a squared minus ab plus b squared. So there's a way that I like to teach to remember this. It's called using the SOAP. If I spell SOAP right. Using SOAP. Okay, so notice that the arrangement of the variables are exactly the same, right? A, B, A squared, AB, B squared, A, B, A squared, AB, B squared. But what's changing sometimes are the signs. So what does this mean? Okay, so S represents same signs. Okay, so that means negative, negative, plus, plus, same signs. O means opposite. Okay, what does that mean? Opposite. If the first one's negative, this one's positive. The first one's positive, this one's negative. And then AP, well, what in the world does that mean? Always positive, positive. Always positive. Okay? So, always positive, always positive. That's kind of a weirdo way of remembering how to remember the factor patterns for this. All right? So, let's go ahead and do it now. So now that we have our factor pattern, we're going to, of course, use this one here because it's subtraction, it's a difference. So let's write it as a cubed minus b cubed. So that's going to be x cubed minus 27 is 3 cubed. So this means that a is like your x and b is like 3. So to write that out, that's going to be x minus 3 times x squared plus x times 3 plus 3 squared. And let's clean that up. That'll be x minus 3 times x squared. X times 3 is 3x plus 3 squared is 9. So that is your final answer. Okay, you can take a quick break. Sorry guys, I gotta get my car serviced, so my boyfriend is picking my car up from work. So if I randomly have to take a quick break, I'm giving him my key. Okay, so probably TMI, but you know, life calls. All right, so add or subtract as indicated. So we're adding rationals. So in order to add a rational expression, fractions, rationals, you must have the same or common denominators. All right. We don't right now. The first denominator is x squared minus 16, and the other one is x minus 4. But what you want to do, you want to be able to identify your factors so you can figure out your least common multiple, which will be your least common denominator. So x squared minus 16 can be factored using the difference of two squares. That's actually x plus 4 times x minus 4. All right? So the first denominator is x plus 4 times x minus 4. The second one is just x minus 4. So our least common denominator needs to have all the factors considered or represented. So we have an x plus 4, and we need to have an x minus 4. And that's it. This would take care of what we see in the first denominator and what we see in the second. So now you figure out, okay, so what's missing in each denominator? So the first denominator is fine. It is what we needed for it to be. The second one is missing a factor. It's missing an x plus 4. So we need to multiply that by x plus 4. But if I multiply the bottom by x plus 4, I have to multiply the top by x plus 4. So now let's see what we have. So if we add this up, we're going to keep that denominator of x plus 4 times x minus 4. But now we're going to combine the top. So 3x plus x times x plus 4. So let's distribute. First we have 3x, now let's distribute. X times x is x squared. X times 4 is positive 4x divided by x plus 4, x minus 4. Let's make sure and see if we can factor the top. So we want to change the order of the numerator to be in standard form. So we're going to write x squared first, then 4x. Oh, sorry. 3x plus 4x are like terms. Totally missed that. These are like terms. So 3x plus 4x is 7x. And then over x plus 4, x minus 4. Okay, so you could factor out an x in the numerator and get x plus 7. But doing that doesn't help you simplify because you can't cross out anything. So you can actually leave your answer like this. This is okay, but you don't have to go that further step. The only reason why you want to factor out the x in the numerator is if something canceled out. But since nothing cancels out, you can actually keep it as the answer that I have boxed in. Okay. Let's look at 12. Simplify the complex rational expression. So, to simplify a complex expression, we're going to do something called clearing out the fractions. So we're going to multiply the top and bottom by the least common denominator. So you're going to look at all the denominators here. So yes, we have a big numerator and a big denominator, let's look at them separately. So in the numerator, the denominator is x, and in the denominator it's also an x, so the least common denominator is x. So we're going to multiply the top by x and the bottom by x. So what does that look like? That looks like, let's see, can I keep the pins here so I'm not having to keep trying to see if I can keep it there. But anyway, okay, so we're going to have x times 2 plus x times 1 over x, all divided by x times 8 plus x times, no, that's a minus, sorry guys. This is a minus, like that. So we distributed this x with every single term in the numerator and denominator. So x times 2 is 2x. Then x times 1 over x, the x's cancel out, and we just have plus 1. Over x times 8 is 8x. And then negative x times 1 over x, the x's cancel out, and we have minus 1. And you cannot factor the top or bottom, so this is going to be your final answer. So you're going to multiply the top and bottom by whatever the least common denominator is between all of the denominators in the problem. Okay. 13. Solve the rational equation. So to solve the rational equation, it's kind of similar to how we simplified the complex expression. We're going to find the least common denominator, and we're going to multiply the entire equation by the least common denominator. So we have an x plus 6, so that needs to be a part of our LCD. And we have an x, that needs to be a part of our LCD. So we're going to multiply every single term by that least common denominator. So I'm going to write it all out so you see what we're doing. And the reason why we're doing that is because it actually gets rid of all of the fractions. Okay, so the first expression, x plus 6, those are going to cancel out. So we just have x times 5, which is 5x, plus, here the x's cancel out, and I have positive 2 times x plus 6 equals, and on the right I've got, let's go ahead and say 2x times x plus 6. So let's do some multiplication. So 2 times x is 2x. 2 times 6 is 12. I'm going to bring down that 5x equals 2x times x is 2x squared. 2x times 6 is 12x. Okay, let's combine like terms. So 5x plus 2x is 7x plus 12 equals 2x squared plus 12x. Okay, so we're going to start to solve this. So we need to set it equal to 0, and I'm going to have a quadratic. So I want the leading coefficient to be positive, so I'm going to keep that 2x squared on that side and move the 7x and the 12. So I have 0 equals 2x squared. 12x minus 7x is 5x. Then bring down that minus 12. So now I need to factor this trinomial. So the way that I like to factor trinomials, I like to use the AC method. Okay, so let's see here. I use a few methods. So I'm going to use the AC method and see if that makes sense for you guys. So I'm going to take 2 times negative 12, which is negative 24. And I want to think of 2 numbers that multiply to give me negative 24 and add to give me 5x. So those 2 numbers, let's see, 8 and 3. So 8 times negative 3 is negative 24, and then 8 plus negative 3 is positive 5x. So I'm going to use those 2 numbers to rewrite 5x and say that is 8x minus 3x. And then I'm going to rewrite 2x squared and minus 12. Now I'm going to use factoring by grouping. I am going to need another page. Let's see here. Hopefully that page went where I want it to go. Nope. Hold on. Oh, jeez. There we go. No, it didn't do it again. Okay. I'm trying to insert a page. Okay. It's supposed to work so much better. Okay, hold on, guys. Technical difficulties. Let's see. I don't want it there. I want it. Okay, does that work? Here we go. Okay. All right, here we go. So now we're going to solve this by factoring. So I've got, all right. I'm going to start by grouping the first 2 and the second 2. Factor out the GCF, which is 2x. And we have x plus 4 in parentheses. Then factor out the GCF here, which would be a negative 3. So we're going to have x plus 4 in parentheses. So I have x plus 4 times 2x minus 3. That equals 0. So to solve this, I'm going to set each factor equal to 0. And I'm going to solve each one for x. So x equals negative 4. Here to solve for x, I would add 3 first. 2x equals 3. Divide by 2. So x equals 3 over 2. So your 2 solutions are negative 4 and then 3 over 2. And then when you put it into the computer, you type it in, it's going to ask for you to type it as a solution set. So you can just list it within the brackets they give you. So you can say negative 4, comma, 3 over 2. You can actually write whichever order you want, and they'll take both of them. All right? But remember, in the beginning, we had to multiply by the LCD throughout the entire equation to then get rid of those fractions and then go ahead and solve. Sometimes you have a quadratic to solve, which is what we had here, because we had an x squared term. Sometimes you don't, and you can solve it because it's a linear equation. Okay, so let's keep going. Number 14, a pool can be filled by one pipe in 3 hours and by a second pipe in 6 hours. How long will it take using both pipes to fill the pool? So there's a little formula you can use. 1 over time 1 plus 1 over time 2 equals 1 over together, 1 over big T. So we're going to solve for T. How long will it take for them to both fill the pool? So T1 will be the first time, T2 will be the second time, and we're going to solve for T. So we're going to say 1 over 3 plus 1 over 6 equals 1 over T. So to solve this rational equation, we're going to do just like we did before, find the least common denominator and multiply the entire equation by that least common denominator. So we have 3, 6, and T. So what's the least common multiple between 3 and 6? Well, that's just 6. And then we need to have T. So 6T is our least common denominator. So we are multiplying 6T everywhere. So 6T times 1 over 3. Well, 3 can go into 3 once, and 3 can go into 6 twice. So we actually just have 2T. 6T times 1 over 6. The 6's cancel, and we have plus T equals 6T times 1 over T. The T's cancel, and we just have 6. So 2T plus T is 3T equals 6. And to solve for T, we'll divide by 3. So T equals 2. So it will take 2 hours for them to fill the pool using both pipes. Okay? But this is the formula you would use for all the those work problems like this. Okay. 15, rationalize the denominator. So in order to rationalize the denominator, we're going to multiply the top and bottom by the conjugate of the denominator. And all that means is that you change the sign of what you see. So we're going to multiply the top by root 3 plus 8, and the bottom by root 3 plus 8. Okay, so at the top we have 9 times root 3 plus 8. And at the bottom we have root 3 minus 8 times root 3 plus 8. Okay, so at the top we're going to distribute that 9. So we have 9 root 3 plus 9 times 8 is 72. Okay, now at the bottom we're going to FOIL and distribute. So root 3 times root 3 equals root 9, which equals 3. Okay. Then outer root 3 times 8 is 8 root 3. Inner negative 8 times root 3 is negative 8 root 3. And then last, negative 8 times 8 is negative 64. Okay, in the denominator, 8 root 3 minus 8 root 3 cancels out. And all I have left in the denominator is 3 minus 64. At the top, it's 9 root 3 plus 72. And then now we need to do 3 minus 64, which is negative 61. So we have 9 root 3 plus 72 over negative 61. You can also write that as negative and then 9 root 3 plus 72 over 61. And that's your final answer. Okay. All right, let's keep going. 16, simplify and express the answer with positive exponents. So we have x to the 1/3 times x to the 1/3 minus x to the 2/3. Okay, so we're going to distribute. Okay, we're going to distribute. So we have x to the 1/3 times x to the 1/3. And then we have minus x to the 1/3 times x to the 2/3. So when we multiply exponents with the same base, we add the exponents. So that's going to be x to the 1/3 plus 1/3 minus x to the 1/3 plus 2/3. All right, so now when we add exponents, they have to have the same denominator, which, lucky us, we do have that. So that's going to be x to the 1 plus 1, which is 2/3, minus x to the 1 plus 2 is 3/3. And then 3/3 equals 1, so that's just going to be x to the 2/3 minus x to the 1st. And we can just write that as x to the 2/3 minus x. So this problem is just really getting you to use those exponent properties with fractions. Okay? All right. 17. A basketball player's hang time is the time spent in the air when shooting a basket. The formula T equals square root of D over 2 models supposed to be hang time, T, in seconds, in terms of the vertical distance of a player's jump, D, in feet. When a particular player dunked a basketball, his hang time for the show was approximately 1.29 seconds. What was the vertical distance, D, of his jump, rounded to the nearest tenth? So long story short, we're going to use the formula T equals the square root of D over 2, and we're going to solve for D. So that means we have to know the other variable. T is the time in seconds. T is going to be 1.29. So we're going to say 1.29 equals the square root of D divided by 2. And we're going to solve for D. So to start solving for D, we're going to multiply by 2 to get rid of that in the denominator. Because that's going to cancel out. And on the left, 2 times 1.29 is going to be, using the calculator, 2.58 equals the square root of D. Now, to get rid of the square root, we're going to square it on both sides. That's going to get rid of that square root. So on the left, 2.58 squared is 6.6564. That equals D. And they want you to round that to the nearest tenth. So that's important, guys. So let's see. So we have 6.6564. The nearest tenth is right here. So we're going to look at the number to the right. We're looking at this. If that number is 0 through 4, we're going to keep that 6 here the same. If the number circled is from 5 to 9, we're going to round that 6 up. So since this is a 5, we're going to round this to 6.7 feet. So that is your final answer. Okay? All right. Check for any questions. Nope, I don't see any. Okay. 18. Solve the radical equation. So we're trying to solve for x. So we have a radical equation, so we want to get rid of that radical so we can start to solve the equation. So you want to get the radical by itself, which we already have it by itself here. So now we're ready to undo the radical. So we're going to square it. It's a square root, so we're going to square it to cancel out the radical. But if we square the left, we have to square the right. So that's canceling out that radical. So on the left, I just have 14x plus 9. And on the right, I have x plus 3 squared. Now, that means that is x plus 3 times x plus 3. So let's FOIL. X times x is x squared. Outer, and I'm saying FOIL. Outer, x times 3 is 3x. Inner, 3 times x is 3x. And last, 3 times 3 is 9. Okay, so now I have 14x plus 9 equals. Let's combine like terms. So we have x squared plus 6x plus 9. And we're solving this, so we need to set this equal to 0 to start solving this. So let's see here. Okay, so let's move the 14x and the 9 to start to solve this. And we must set it equal to 0. Equals x squared. 6 minus 14 is negative 8. So we have negative 8x. And 9 minus 9 is 0. So that cancels out. So now I'm going to solve this. I'm going to factor x squared minus 8x. It has a GCF of x. When I factor that out, I have x minus 8 in parentheses. So now that I have factored it, I'm going to set each factor equal to 0. So I already have one solved. The other one, I'm just going to add 8 to get x by itself. So x equals 8. So my solution set is going to be, this is how you want to type it into MyMathLab, 8, 0. Or you could have written 0, 8. That's fine as well. All right. Biggest thing here is to do not just say, when you have x plus 3 squared, don't just say x squared plus 3 squared. That is not correct. All right. Okay. 19. Divide and simplify to the form a plus bi. This is another example where you're going to multiply by the conjugate of the denominator. So we're going to multiply the top and bottom by 9 plus 2i. So at the top, we're going to have 4i times 9 plus 2i. At the bottom, we have 9 minus 2i times 9 plus 2i. So at the top, we're going to distribute that 4i. So we have 4i times 9 is 36i. And then 4 times 2i is 8i squared. Divided by, we're going to distribute here. So 9 times 9 is 81. 9 times 2i is 18i. Negative 2i times 9 is negative 18i. And then negative 2i times 2i is negative 4i squared. Now it's super important here. I squared equals negative 1. So that's something that we learned when we were talking about complex numbers. Whatever you see in I squared, you want to immediately switch it out for negative 1. So here and here, I'm going to change that to a negative 1. All right? So this is actually going to be 36i plus 8 times negative 1 over 81. 18i minus 18i cancels out, minus 4 times negative 1. So now I have 36i minus 8 over 81 plus 4. So that's going to be 36i minus 8 over 85. Now, I want you to write the answer in a plus bi form. So we're going to switch the order around here. That's going to be negative 8 plus 36i over 85. And if we split that up into two separate terms, that'll be negative 8 over 85 plus 36i over 85. And that is going to be your final answer. But super important is that you pay attention to when you get an I squared, immediately swap that out for, okay, what's going on with my computer? Okay, immediately swap that out for negative 1. Okay, number 20, solve the equation by the square root property. So we want to get the squared term by itself before we take the square root. So I'm going to divide by 3 first. So x plus 7 squared equals 60 divided by 3 is 20. Now I'm ready to get rid of that square using a square root. So on the left, that cancels out the square, and I have x plus 7 equals. Now, when you're solving an equation and you take the square root, that's going to be plus or minus the square root of 20. Okay? Now, you can simplify the square root of 20. Let's do that over here. So the square root of 20, let's break that down into, let's see, 5 times 4, 2 times 2. We're looking for pairs of the same number. We have a pair of 2's. Root, what's left over is the 5. So the square root of 20 is the same thing as 2 root 5. This is going to be x plus 7 equals plus or minus 2 root 5. But I'm solving for x. I'm going to subtract 7. So the answer is going to be x equals negative 7 plus or minus 2 root 5. If you have to write that as two separate answers, that's just going to be negative 7 plus 2 root 5, and then negative 7 minus 2 root 5. So this plus or minus would be here and here. But that would be your final answer, or these two numbers. Okay? All right, let's look at 21. An 18-foot ladder is placed against a vertical wall of a building. So let's draw that. Whoa, let's draw that building. That's a building. I'm an artiste. Okay, an 8-foot ladder is placed against a vertical wall. So like here's the ladder here. With the bottom of the ladder standing on level ground, 12 feet from the base of the building. So this is 12 feet. How high up the wall does the ladder reach? And the ladder is 18 feet long. This is 18 feet. It's asking how high up the wall does the ladder reach. It's asking for this amount here. So we'll call this x. Now, when you're doing these problems, the assumption is that these buildings, it's a vertical wall, so it's straight up and down. It's assuming that the ground is level. This is going to be a right angle. So we have a right triangle, so we're going to use Pythagorean theorem. A squared plus b squared equals c squared. All right? So it's looking for one of your legs. So remember that your hypotenuse, C, is always opposite of the right angle, but A and B, it doesn't matter. Just for the sake of this, I'm going to make A here and B here. So using the values that we know, we're going to say x squared plus 12 squared equals 18 squared. So x squared plus 12 squared is 144 equals 18 squared is 324. To solve for x, we're going to subtract 144. Excuse me. 324 minus 144 equals 180. So x squared equals 180. And to solve for x, I'm taking the square root. So x equals plus or minus the square root of 180. Let's put that in the calculator. The square root of 180 is going to be 13.416. So we'll say that's 13.42. But I said plus or minus. But we're talking about the height of a wall. So we don't want the negative value. We just want the positive value. So the answer will be 13.42 feet. And I believe the problem tells you how to round. So just follow however they tell you to round when you're doing the problem. Let me look at this real quick. 21. Yeah, it says round to the nearest hundredth in your answer. So it was actually 13.416. So because of that 6, we round the 1 up to 13.42. But Pythagorean theorem was the important thing here for all right triangles. 22. Solve the following equation using the quadratic formula. So, a few things. First off, you do need to know the quadratic formula. And you also need to have your equation in standard form in order to use the quadratic formula. So ax squared plus bx plus c equals 0. It has to be in that form. And then the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So first, let's put it into standard form. So we're going to subtract that 1. And we'll have 2x squared minus 11x minus 1 equals 0. So now we need to identify our variables a, b, and c. So a equals 2, b equals negative 11, and c equals negative 1. So we're going to take these values and plug them into our quadratic formula. Negative b, so negative times negative 11, plus or minus the square root, b squared, negative 11 squared, minus 4 times a times c, all divided by 2a. Just so you follow along with what we did, I'm going to use my colors. So, negative b plus or minus square root of b squared. Let's see where the a is. So we have minus 4ac, all divided by 2a, and then the c is here. I just want to make sure you see where these values came from. Oh yeah, blue. Okay, my colors were confusing me. Here we go. So now let's simplify this. So negative times negative 11 is positive 11, plus or minus. Negative 11 squared is 121. Negative 4 times 2 times negative 1 is positive 8, all divided by 4. So we've got, all right, so 121 plus 8 is 129. So we have 11 plus or minus the square root of 129 divided by 4. And 129, we cannot simplify that further under the square root. So that's actually our final answer. And again, if you wanted to write that as two different numbers, like separately, that'll be 11 plus square root of 129 over 4, and then 11 minus the square root of 129 over 4. Okay, so we have another word problem. If you can see it, the computer stops jumping around. Okay, a ball is thrown straight up from a rooftop 448 feet high. The formula h equals negative 16t squared plus 72t plus 448 describes the ball's height above the ground, h, in feet, t seconds after it was thrown. The ball misses the rooftop on its way down and eventually strikes the ground. The graph of the formula is shown with tick marks not labeled along the horizontal axis. How long will it take for the ball to hit the ground? Use this information to provide tick marks at the appropriate numbers along the horizontal axis in the figure shown. Okay, so we need to, so when it asks you, how long will it take for the ball to hit the ground? So the hit the ground part, that means that your h equals 0. That means there's a 0 height, 0 feet in height, right? That's what that means. So that's going to be 0 equals negative 16t squared plus 72t plus 448. So we're going to solve for t. What is the time when the ball hits the ground? What is the time when the height is 0? So let's check for a GCF. Let's see if maybe 16 can divide into both of these. So 16 cannot go into 72. What about 8? Let's try 8. Okay, 8 can divide into 72. What about 448? All right, that's our ticket. So the GCF is going to be 8. Let's factor out a negative 8 to get rid of that negative leading coefficient. So we're going to have 2t squared plus, this is going to be, well, not plus, we're factoring out a negative, so that's going to be negative 9t. That's going to be negative 56. Okay, so we can solve this by factoring, or we can use the quadratic formula. Let's use that just to get some practice. So we're going to now solve in here. All right, so let's see. So A equals 2, B equals negative 9, and C equals negative 56. So X equals negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. So that's going to be negative times negative 9 plus or minus the square root, negative 9 squared minus 4AB divided by 2 times A. Okay, so we've got positive 9 plus or minus the square root of negative 9 squared is 81. Negative 4 times 2 times negative 56 is positive 448. 448 plus 81 is 529. Jumping ahead. 9 plus or minus the square root of 529 over 4. And the square root of 529 is 23 over 4. So we've got two different numbers going on. We have 9 plus 23 over 4, and then 9 minus 23 over 4. So 9 plus 23 is 32, divided by 4 is 8. 9 minus 23 divided by 4 is negative 3.5. Now let's look at your graph. So notice how the parabola, it cuts off here. If we were to keep going, it would be like that. But we don't care about negative time. That's why we are only showing this blue part of the graph. But this gray dotted line that I drew to symbolize the rest of the parabola, that's where this comes from. All right? So that's why we don't want that. We don't want that answer. We only care about this answer because this relates to this value here. Okay? So if this is 8, the tick marks have to be by 2s, right? That would have to be, this is 2, 4, 6, 8. So how long will it take for the ball to hit the ground? 8 seconds. 8 seconds. Okay? Okay. 24. Find the coordinates of the vertex for the parabola defined by the given quadratic function. So it's in standard form, so we have to use the vertex formula. So the vertex formula tells us the x-coordinate of the vertex. So that vertex formula is x equals negative b divided by 2a. So we get that a and b from that standard form, ax squared plus bx plus c. So in this case, a equals negative 1 and b equals 6. We got that from here and here. Let's plug those values in. So we have negative b, which is 6, divided by 2 times a, which is negative 1. So negative times 6 is negative 6, divided by 2 times negative 1 is negative 2, and negative 6 divided by negative 2 is positive 3. So the vertex is a point, and it's going to be 3, comma, some number we don't know. To get that some number we don't know, that's going to be f of 3. That's what goes there. So we take what we have for x and plug it into our function. It's going to be negative 3 squared plus 6 times 3 plus 10. We're taking this 3 and plugging it in everywhere we see x. So now, just 1 second. Okay, sorry guys, I had a colleague that had to tell me something. Okay, where were we? Now, 3 squared, exponents first, so that's going to be negative times 9 plus 18 plus 10. So we have negative 9 plus 18 plus 10, which is going to equal 19. So the vertex is going to be 3, 19. That's the answer. 3, 19. Okay, drum roll please. Number 25. Use the vertex and intercepts to sketch the graph of the quadratic function. Then use the graph to determine the range of the function. I should have put a coordinate plane here, but I'm going to freehand it. So this is in what's called vertex form. So remember, vertex form looks like this. A times x minus h squared plus k. So the it's called vertex form because it tells you the vertex just by looking at it. It's h comma k. But I like to refer to this as change the h and keep the k. What in the world does that mean? That means that whatever you see here for x minus h, whatever number you see in the parentheses, you change the sign to get the x coordinate of the vertex. And then whatever you see here plus k, you keep that sign the same. So for example, here we can just look at this and find the vertex of this function. So if we change that plus 1, the vertex, the x coordinate is going to be negative 1. Change the h, keep the k, so the y coordinate is negative 4. So change the h, keep the k. So that's the vertex. So let's see, I'm going to make my little graph here. So negative 1, negative 4. That is the vertex. So now we want to get some x-intercepts. So to get x-intercepts, that means that y equals 0, or rather f of x equals 0. So 0 equals x plus 1 squared minus 4. Let's solve for x. So I'm going to add 4 to both sides. So 4 equals x plus 1 squared. I want to take the square root to get rid of that square. So that's plus or minus the square root of 4, which is 2, equals x plus 1. And then to solve for x, I'm going to subtract 2. So what's happening is that I have x equals negative 1 plus or minus 2. So that's going to be negative 1 plus 2 and negative 1 minus 2. So negative 1 plus 2 is positive 1, and negative 1 minus 2 is negative 3. So those are your x-intercepts. So let's see. So that's going to be 1 and negative 3. So I have enough information to sketch my parabola. Now let's talk range. So the range is referring to your possible y values. So we go from bottom to top. So it starts here at y equals negative 4. It's going from negative 4 and up. So the range is going to be a bracket at negative 4. And it's going all the way up to infinity with parentheses. All right? And that's it. So, what was I going to say? That was the final exam review. So I did a version of what you will see. You can do that multiple times. I strongly encourage you to do this review a ton of times. Please don't go away. Come back, screen. Okay. I don't know what it's doing. Okay, it's back. So you have multiple times to do the final exam review. I encourage you to do that tons of times. You have until next Friday to do your final exam in the testing center. Please don't wait to the last minute. Don't do that because grades are due Monday, and you have the entire week to take the final exam. So do not wait to the last minute, guys. Please don't do that. The testing center, I think, closes at 9. If you want your full 2.5 hours, you need to get there at an appropriate time. You can use a graphing calculator, and you need to have your VID and your CRN for the class. This is 21595. That's the CRN, and of course my name. But I have a lot of different online classes, so make sure that you know which class you're in. I know that sounds obvious, but just make sure. Oh, you're welcome. I gotta thank you. Y'all are the sweetest class. Like, y'all are so nice. Y'all have been really great to work with. So I'm going to post this video shortly. It may take a second for it to populate. I'm going to post it in the class so you can rewatch this as many times as you need to. Please don't hesitate to send emails with questions if you have them. Come down to the depot if you are ever on campus. The library at the Osceola campus is going to have extended hours Monday through Wednesday, I think. Maybe even Thursday, but I know Monday through Wednesday. They're actually going to be open till midnight on those days. And then on Monday and Tuesday, we're going to have somebody from the Math Depot available from 8 to 12 p.m. to help you if you need help. So math-specific tutors. But you guys also have Smart Thinking. Well, everybody has Smart Thinking, but remember, Smart Thinking is a free online tutoring service that you can use at any time. But yeah, we are in the home stretch. Also, I will use your final exam grade to replace your lowest test grade if that helps your grade any. So if you had that one test that wasn't so hot, please push forward and do the best that you can on this final, because that can replace one of your lowest test scores. So I think that is it. I really am proud of you guys. You guys are a great class. You're proactive. You're staying on top of your assignments. We're in the home stretch here. So if you have any questions at all, you know what to do. Come contact me. And I'm going to post this shortly as soon as it finishes loading. So are there any final questions that you guys have? Yes. Yes, all of my intermediate. There you go. So they're good. I was answering a question. I have multiple online classes, and I'm doing that same thing with the final exam. The final exam will replace the lowest test grade. So, cool. All right. So I'm going to get off now. You guys have a great rest of the week. Have a good weekend. And breathe. Don't stress. But, you know, do finish strong. So I will see you guys online. Thank you, guys. See you later.